Hello, welcome to this presentation dedicated to short-term project subtask, aiming to demonstrate how innovative solutions developed in promotion could be implemented in short term in the real life. Some words about myself. My name is Maksym Semenyuk. I am energy markets consultant at DNVGL. Within promotion, I have been coordinating short-term project studies and have contributed to the deployment plan at an earlier stages of its development. Interestingly, I have been involved in promotion from two different organizations, originally during my master internship at TenneT and presently as a full-time consultant at DNVGL. Therefore, I am very familiar with how the project has evolved and reached its completion. It also gave me a chance to contribute to different work streams within Work Package 12. In this presentation, I will introduce you to the short-term projects that have been explored within promotion, explain what kind of studies were performed, and give examples of how some of the promotion findings could be implemented in real life. I have to start this presentation with a small disclaimer that you can see in front of you. All of the projects that will be described are theoretical proposals developed within promotion for research purposes. Project owners have supported us by providing inputs, but they do not commit to implement anything not described. At the same time, we will be happy to share more information with those who are interested, although we will need to ask for project owners' permission. So please feel free to approach myself if you would like to learn more, and I will connect you with relevant parties. Now let's move on to what are the actual objectives of implementing such projects. Although deployment plan looks at the timeline up to 2050, it was clearly concluded that the first actions need to be taken now if we want to achieve the ambition of having a meshed offshore HVDC grid on time. As such, short-term projects allow to further raise technology readiness level of HVDC equipment from lab to commercial level. They facilitate further development in the area of technology interoperability. Depending on the project, they can improve social benefits, allow to test new regulatory and market arrangements. In other words, they serve as the next steps towards implementation. This diagram shows different stages of how grid development paradigm has to evolve to come from the business as usual point-to-point connections, so on the left-hand side, towards complex multi-terminal HVDC projects that you can see on the right-hand side. Looking at the last three steps of this diagram, we have identified existing or planned projects where these arrangements could be implemented. We have initially identified 6 projects that allow some of the typical elements of a meshed offshore grid to be deployed. Eventually, we have done pre-feasibility work on 3 of them, which you see in bold font. Southwest Link and Hansa Power Bridge, WindConnector and Clean Stream, Bornholm Energy Hub. Also, we have had some dissemination workshops with North Sea Wind Power Hub to discuss their specific issues. This slide gives an overview of the types of studies we have performed for these projects. The analysis that we have performed is a pre-feasibility kind of studies based on the information that was made publicly available. At the same time, we did manage to cover very different topics ranging from technical investigations of dynamic faults, grid topologies, and protection system design, to the analysis of financing approach, ownership schemes, market arrangements, and obviously cost-benefit analysis. The first project on our list is DC connection between Southwest Link and Hansa Power Bridge. These 2 DC cables have one of their ends landing at the same substation in the south of Sweden in Hurva, as it is shown on this map. As most of the power flows are going from the north to the south of Sweden and further to Germany via Hansa Power Bridge, promotion proposed to implement a connection between these links on the DC side in order to avoid conversion losses and increase the redundancy of this transmission path. Such project would allow to pilot in the real life one of the main components investigated in promotion, HVDC circuit breaker. Here is a diagram of how this could potentially look like, where in the red color we mark the additional DC link that allows power flow to bypass HVDC converters and removes the need to convert from DC to AC and again to DC. A range of technical studies related to the control and protection of such systems has been performed. Promotion has investigated how such link could be implemented. What would it mean in terms of space requirements and connection points, which extra equipment would be needed, and so on. Although in certain cases the link could be profitable due to the saving on avoided losses and due to increased availability, it is worth to emphasize that nothing like this has been implemented before. Therefore, there are many potential risks which are hard to capture by a simple cost-benefit analysis. These risks are remaining and they would have to be addressed in the real life. So promotion hasn't investigated all of them, and we do recommend to study them further. The next project that has been explored is a so-called WindConnector cable, where promotion looked at the possibility to implement DC circuit breaker-based protection. On this map, you see a schematic representation of the project. WindConnector is a DC cable that is supposed to connect two offshore wind farms, Dutch and British. The idea of the project is that during the times of low wind, energy can be traded via this cable, therefore eliminating the need to build a separate interconnector between two countries and allowing to combine functionality of energy evacuation and energy trading. There is a number of issues pertaining to such concept, including regulation of the cable, market arrangements, and protection of wind farms and onshore grids. Promotion has considered some of these issues, but within short-term project, the focus was on the protection and market arrangements. A number of technical studies was performed, and the goal was to design the protection system in such a way that potential failure on either British or Dutch wind farm would not affect onshore grid of another country through the WindConnector cable, and would not require to shut down entire system to clear a fault. Promotion experts have investigated what can be the consequences of different failures on either side and how an electric fault would propagate towards onshore grids. A range of specifications for converters, control systems, DC circuit breaker, and inductor were suggested. It is believed that this project offers an opportunity to utilize HVDC circuit breaker to ensure security of the system. Certainly, there is a range of issues that were not explored within the promotion. There is a compromise to be achieved between the benefits from having a very sophisticated, fully protected system with DC circuit breakers, where any fault can be isolated without interrupting power supply, against a more simple approach, where in case of a failure, entire system is de-energized and then brought back only once a fault is cleared. Furthermore, WindConnector project is a perfect example of project where the concept of hybrid assets or offshore bidding zones could be required to be implemented. According to European law, there is an obligation to make at least 70% of cross-border interconnection capacity available for trade. For WindConnector, this cannot be achieved when generation of Dutch wind farm is above around 700 megawatts, or generation of UK wind farm is about 500 megawatts. For better understanding, the total capacity of these farms is just twice the numbers that I said. So basically, whenever the generation is above 40 or 50%, this goes against the European laws. So both concepts of hybrid assets and offshore bidding zones are described in detail by my colleagues in the other breakout session of the previous week dedicated to legal and market studies. These concepts have investigated how to improve the business case of such an asset and allow their construction in the future. Finally, promotion has investigated the proposed project of building energy hub on the Danish island of Bornholm, which has been recently included by Danish ministries in their climate plans. Here you can see the schematic representation of this project. If realized, it would address most of the existing barriers to large-scale offshore wind deployment. DC protection with DC circuit breakers, multi-vendor and multi-purpose systems, regulatory and economic models. We know that Bornholm Island offers unprecedented opportunity to minimize the amount of infrastructure that would be required otherwise to connect 4 different European states. Geographic position between Nordic and Central European regions make it a perfect candidate for the development of a first multi-terminal European energy hub connecting Denmark, Sweden, Germany, and Poland. Promotion has performed a broad range of studies which are impossible to capture in this short presentation. So on this slide, I'm just giving you one example. Here we show how DC hub pilot could be implemented in a stepwise manner by first building interconnection between Denmark and Poland with an intermediate DC point of connection, then connecting wind farm, and then extending the hub to other countries. The benefits of such an approach include managing technical complexity at early stages and reducing procurement and operational risks. And finally, we come to some high-level conclusions. During the past 5 years, promotion projects brought technology to the lab testing level. We think that identifying projects such as Bornholm, WindConnector, Southeast Link, and Hansa Power Bridge described above is a cost-effective way to deliver a test environment within real projects. Within promotion, we have performed preliminary studies to support this real project, and we think that technology is ready, but there are outstanding risks relating to procurement, interoperability, multi-vendor contract management. Our identified projects try to minimize these risks, but there are still issues to solve. We also note that motivation has to be there in order to proceed with implementing these projects in the real life. Finally, here you can see all the different partners within promotion project, which in one or another way have contributed to the short-term project studies. I would like to once again thank you to all of them for their tremendous efforts. Thank you for your attention. Please feel free to approach myself for further questions via the contact details that you can see on the screen. Thank you.